Welcome. The objective of this video is to introduce you to inequalities and interval notation. A few of the symbols that you need to be familiar with are the equality symbols. One of them is the less than symbol. The less than symbol is an arrow that looks like it's pointing to the left. The greater than symbol is a symbol that looks like it's pointing to the right. The less than or equal to symbol is an equality symbol that has a little bar underneath it, meaning that the value can actually be the same as well. The greater than or equal to symbol is a symbol that has also a little bar underneath it. The equal to symbols are regular equality sign, equal sign, and not equal to is an equal sign with a diagonal slash going through it. When we're talking about equality statement or inequality statements, that means that there's a range of answers that are possible. Another way we can do this is interval notation. Interval notation is a new notation to most of you. In interval notation, there's a few symbols that we need to be familiar with. They're symbols that we're used to seeing in regular grammar or regular life. That is the parentheses and the square brackets. Now, just like with equality symbols, we have some that mean that it can also be the same as. For example, as we're looking at number 7, in number 7, we have an inequality statement where x is greater than 8, meaning any value you plug in, 9, 10, 11, or even 8.5, makes the statement true. 8.5 is greater than 8. But in this particular example, we cannot include 8. 8 is not greater than 8. But we can choose values like 8.1. Numbers really close to 8 make this statement true. Even 8.01 is greater than 8. To denote this in a graph, what we usually do is we draw a few numbers on the number line. Now, for our class and our purposes, we only need 3 numbers. 8 being the key number, it is our boundary point. It's just right there on the line of making the statement true or not true. And then we're going to include numbers on either side. And the number line, it always goes from the smallest to the largest. So 7, 8, 9. Now, because 8 is that boundary point, in other words, that's where it's going to be define our true and not true statements, in a graph, we put an open circle on top of 8. This open circle means that we can have values close to 8, but 8 is not actually going to be an answer. Then we shade all of the values bigger than 8, which means we're going to go to the right on the number line. Okay, we darken in this arrow to let us know that this goes on forever. In interval notation, the nice thing about this, it only requires 2 values. The first one always needs to be the smallest. In this case, the smallest value that we could be is 8, but we want to make sure that we don't include 8. 8.1 would be okay, but not 8. In interval notation, when we put a parenthesis, that means it does not include the value. So we're going to put the open parenthesis here, 8, and then we want to say that this goes on forever. A number like 1,000, but even 1,001 is greater than 8. 1,000,000 and 1,000,001 are both greater than 8. This goes on forever. In math, the symbol that means forever, is the infinity symbol. The infinity symbol looks like a sideways 8. It takes a little practice getting used to drawing. And then the infinity is a concept. It's not, we cannot actually ever reach infinity. Because we can't ever be infinity or actually equal infinity, we are always going to approach infinity. Infinity always gets a parenthesis. In this next example, in example number 8, we have the value x is less than or equal to 8. In this case, 8 less than or equal to 8 is a true statement. So when we put the circle on 8, we're going to go ahead and fill it in. We're going to choose values like 7, 8, and 9 just to go around it. And then we're going to choose all the values less than or equal to 8. Now, if our variable is on the right-hand side of our inequality, or left-hand side of our inequality statement, then this little arrow here will help us because it matches this same arrow here. This is always true if the variable is on the left-hand side. Now, in interval notation, we want to go from the smallest value to the largest. As we can see on the number line, the smallest value is negative infinity. So we're going to go from negative infinity all the way up until 8. Now, infinities always get parentheses because even negative infinity is a concept. We can never actually reach a negative infinity. We'll always keep walking in the negative direction and get close but not quite reach it. 8, on the other hand, we can be 8. If we plug 8 into this inequality statement, it makes the statement true. 8 is less than or equal to 8. So to denote an interval notation that we can equal the value, we're going to put a square bracket. In example number 9, again we're dealing with the number 8. So we're going to put either number on either side, 7, 8, 9, and we do not include 8. 8 is not less than 8. On the other hand, 7.9 is less than 8. So we're going to shade all the values less than 8, and we're going to darken in the arrow. In interval notation, our smallest value again goes backwards on forever towards negative infinity, and then it goes all the way up until 8. We're going to put a parenthesis around 8 because we're not going to include 8, and negative infinity or any infinity always gets a parenthesis in interval notation. In example number 10, we've got again the value 8. So we're going to put 8 on our number line. We're going to go 7, 8, 9, and then we're going to have a circle on 8, but we want to know that it includes 8. So we're going to fill in the circle. We're going to choose all the values greater than 8. 8 is greater than 8, so we've included that with a little open circle. 9 will also work, 10 will work in this inequality, and so forth. So we're going to shade on forever. Now, in interval notation, we always go from the smallest to the largest. That's a rule. In fact, let's write that off to the side in our notes. Smallest to largest. All right, the smallest value is 8. We're going to put a square bracket, and we're going to go off to infinity. This is interval notation. Now, if you would like some more examples, we can go ahead and continue. If you feel like you've got this down, then you can go ahead and work on these examples on your own. In 11 through 14, now this time we have some different numbers besides 8. So we're going to go ahead and use -2. Now in the negative number line, 0 would be here off to the right. You don't have to include 0, but we want to include values that are close to -2. So the number line would go 0, this would be -1, -2, and then -3. -2 is not included, so we're going to put an open circle and we're going to shade all the values greater than -2. Okay, and then we're just going to darken in that line there. When you make your shading, just make sure that it's obvious. Some people like to show that it's above the line. That's also okay. Or you can just do a little squiggly, know that it's shaded in that direction. All right, in interval notation, we want to choose all of the values that are greater than -2. So -2 is our smallest value. We go off to infinity. -2 is not included, so we put parentheses, and infinity always gets the parenthesis. In number 12, again, we have a negative number like -9. 0 would be all the way over here to the right. We would count backwards to -2, -3, and so forth till we get to -8, -9, and then -10. We put an open circle on -9, and we choose the values this time less than -9. So we shade off to the left. All right, in our interval notation, we'd go from infinity, we'd go from -infinity all the way up until -9. Now both of them get parentheses again because we're not including -9 in our options. For number 13, a is greater than or equal to 0. This is a common inequality statement that we see. Most of the time it's not included, but this is saying that any positive number, including 0. So we put 0 here on the number line, then we go either number in each direction, so -1 and 1. In this case, we're going to put a circle on 0, and we're going to fill it in because we can include the value 0. Then we're going to shade off to the right. And then for interval notation, we're going to go from 0, which is our smallest value, up to the very biggest, which is infinity. Infinity always gets a parenthesis, and then 0 gets the square bracket, saying that we're going to include that value. All right, in this last example that we'll do together, we've got values less than or equal to -7. So we put -7 on the number line. We choose numbers on either side of it. For example, as we're going backwards, we're going to get to -6, -7, and -8. We're going to put a circle on -7. We're going to fill it in as we can include the value -7 is less than or equal to -7. That's a true statement. So therefore we can fill this in, and we want to shade all the values smaller than -7. In our interval notation, we're going to go from infinity all the way up to -7. We're going to include -7, and infinity always gets a parenthesis. This concludes the video on interval notation and inequalities. In the next one, we're going to solve simple inequalities and justify our steps and write the answer in interval notation.